Hi guys, welcome back to another tutorial. So, have you ever wanted your Raspberry Pi to understand what you're saying in real time? So in this video, I'll show you how to run a speech to text on a Raspberry Pi 4 using Whisper.cpp and a USB microphone. So, to start, I want to talk a little bit about the objective of this project. So this project aims to turn a spoken audio into text in real time, and I'll be running on a Raspberry Pi 4. This does not require any cloud, no internet processing, and overall it is just a fun study project. So for the materials, I have here a Raspberry Pi 4 Model B. I have a USB microphone I got very cheap from Amazon. And also you need a micro SD card and a micro SD card reader. And for this project, I'm using a female HDMI to a male VGA cable because my monitor doesn't have an HDMI cable port. So yeah, and also obviously the power supply, the monitor, and the keyboard and mouse. So the software that I'm gonna be using is Whisper.cpp, and it is an absolutely free and open source that everyone can use. So how this will work? So first, you will record your audio to a microphone, and then Raspberry Pi will process that audio using Whisper AI to turn that model into text. So to go another level deeper into the AI model, I want to talk about how this model actually works. So your voice is being recorded into the microphone, right? So Whisper AI, it converts that raw audio into a spectrogram like this. So spectrogram is basically just a speech pattern that is being recorded. And next, that audio is being moved to another layer, and this is called, I don't know how to spell it, how to say it. So it's 2x conv 1d plus gel u. Again, this whole thing is on the Whisper AI official website. So this layer clean up the raw audio and it extract the important pattern while reducing the amount of data that is being processed. And next up is the encoding layer. So that audio is then being analyzed through a sinusoidal positional encoding. So what this does is that it slices up every piece of data and kind of mark the position, mark the numbers on it. So you see how, let's say the sky is blue. So you notice how the stands before sky and sky's before is, and is before blue. So this is where it kind of changing all of the output and inputted data into an appropriate position. And the next one is the encoder block. So this audio, then the AI model then trying to interpret, to analyze, and get the meaning of it. Because again, this AI does not output of what is being inputted directly, but it has to understand the context of it. So what this layer does is that it's trying to understand, what are you talking about? What is the context behind this? And next up is the output layer, which is called the cross attention decode. So all of this does is that it lets the decoder to look at the encoded audio for precise word, because you know how you see this, the quick brown. So this decoder will decode the audio based on the encoder block, which it has to understand the meaning of it. So this cross attention makes them to go back and forth and the data flow so that they understand the context that is being outputted. And the last one is tokens. So you see at the bottom here, you say SOT, transcribe, and 00. So what that does is that this AI model it has only one version. So let's say if you do a Spanish version of it, an English version of it, a Vietnamese version of it, it is all the same model, but it uses these tokens to identify of which part of the model is being used. So SOT means that it starts transcribing, EN is the language, and transcribe is when it starts transcribing, and this is just a time stamped. So now you know how this model works.